All right, so let's go ahead and start our next unit today. So we're going to be working on what do we do when we have a quadratic and it doesn't factor. So we know that every quadratic actually has roots and can be graphed. The problem is that sometimes the factors are decimals. So we're going to be taking a look at the quadratic formula and the discriminant today to kind of figure out what their jobs are, how to come up with the values when they're not exactly whole numbers or integers. And we're going to figure out that you can actually factor anything using the quadratic formula. So let's start with how many solutions can a quadratic have? So if you think about a quadratic, I know that I can have a quadratic that crosses the x-axis and has two roots. I can also have a quadratic that only touches once. And I can even have a quadratic that doesn't touch at all, okay? Doesn't touch at all. So I can end up with 2, 1, or 0. And those are going to be important today as we'll take a look at the discriminant. So let's start with refreshing ourselves with what are the roots and how to get them. So this is just a simple factoring. And we can factor this one using the Xbox method. So there's 40 and 22. So I know that's a positive 20 and a positive 2. So 4x squared, 10, 20x, 2x, take out a 2, take out a 4, take out a 2, and take out a 10. So let's take a look at this because we're going to notice that we're not going to come up with the right numbers. Okay, we're not going to come up with the right numbers. So I have 2 times 4, that gives me 8. That doesn't give me 4. Well, why isn't this working? Well, it's not working because it has a GCF in it. So we need to take out that GCF because otherwise this is not going to work. So let's take out a 2. 2x squared, 11x plus 5. Okay, so now when I do my crisscross and I multiply my a times my c, I get a 10 and an 11, so plus 10 plus 1. Okay, so now hopefully it will work. So remember, we got to pay attention to those GCFs. So 2x squared plus 5 plus 10 plus 1. Okay, so we have our 1 here, our 2x, our 1x, and our 5. Now, is this one going to work? Let's take a look at it. So 2x plus 1 and x plus 5. 2 times 5 is 10. 2 times 1 is 2. That will give me 11. Okay, so since I'm trying to solve to find my x-intercepts, remember those are equal to 0. So what we have done in the past is we've set them equal to 0, and that has given us our 2 roots. So one of them is negative 5, and one of them is going to be a negative 1/2, which is here. And since a is positive, I know that it is a smile. Okay, it's a smile. So that's fine if I actually have a decimal root and I have whole numbers here. But what happens when I have a problem like this? So I have 5 times negative 4 is 20, and I have a positive 3. Well, if I think about my factors of 20, that's 1 and 20, 2 and 10, 4 and 5. I have no way to get 3, but this has to factor. Has to factor. So that is where the quadratic formula comes in. Okay, the quadratic formula. It is used to find solutions of the quadratic when the simple factoring is not an option. Okay, so when our integers are not solutions, they're not factors, we know we're going to get a decimal more than likely. And here's the formula. So write this down, make it big, make sure you don't lose any signs. So it's negative b plus or minus, and we'll talk about what that plus or minus is here in a second. And then I have a square root. Okay, Okay, so this is a square root. Showing up in there, b squared minus 4ac all over 2a. Okay, now let's talk about the first part of that and the most powerful part of that. So the most powerful part of this formula is the b squared minus 4ac, okay? So this part under the radical, because it is called the discriminant. And its job is to tell us how many roots or x-intercepts that the parabola has, okay? It's telling us, is it actually touching the quadratic or the x-axis? So if I take a look at this equation, the x squared plus 2x plus 5, a is 1, b is 2, c is 5. So we're going to use b squared minus 4ac, and we're going to see what happens. So b is 2, my 4 is there, a 1, and a 5. So if I multiply this out, so 2 squared is 4, and negative 4 times 1, that's negative 20. So that gives me a negative 16. Well, think about your formula. I have to take the square root of negative 16. Am I going to be able to take the square root of a negative number? Is that going to give me a numeric answer? So let's take a look at that. So if I put in square root, oops, I don't need two of them, of negative 16, it does not like that. It says undefined. Well, how does that work? Okay, how's that work? Well, here's what's going on, okay? If the radical under the discriminant, the value under the radical is negative, that tells me that there are 0 x-intercepts, okay? It is not touching the x-axis. So here's my x-axis, and you can see how my parabola is above it. It's not touching. So there's not going to be an x-intercept if that value is negative. Okay, now there's two other options. There's one where it's 0 and there's one where it's positive. So let's take a look at the 0 one and see what's going on there. So on this one, a is 1, b is 10, c is 25. So 10 squared minus 4 times 1 times 25. Well, 10 squared is 100. 4 times 25 is 100. That gives me 0. Okay, so if the discriminant is 0, that means it's only going to touch once. That means its vertex is the same as its x-intercept or its root. So it's only going to touch once. Okay, it's only going to touch once. Now there's one more type, and that's where it touches twice, and that's the one that we've seen most often. Okay, that's the one where we have seen most often, where it gives us two answers. So in this problem, a is 2, b is negative 7, and c is 2. So negative 7 squared minus 4 times 2 times 2. So negative 7 squared, remember, negative times negative is a positive. Make sure and keep your parentheses. Okay, so if I wanted to do this part in my calculator just to see, just for ease, I'm going to put it in just like I see it. So parenthesis, negative 7, and then my power of 2, minus 4, parenthesis 2, parenthesis 2. And a lot of the discriminant is actually calculator work. Okay, so this is actually 33. So this is going to be 16. So the discriminant is 33. So that tells me that it's going to touch twice. Okay, it's going to touch twice. It's going to be our normal, typical quadratic that we normally see. So they can touch once, it can touch twice, or it can touch not at all. So we need to make sure and understand that if the discriminant, which is the b squared minus 4ac, its job is to tell us how many roots it has. If it is 0, there's 1 root. If it is positive, there's 2 roots. If it is negative, there are no roots. Okay, it's not going to touch. All right, so now let's talk about what determines whether or not something is going up or down. Okay, so we've been having the conversation about smiles and frowns, as we've been kind of working on quadratics in our last unit. So when we have a parabola, what determines if it's going to be a smile or a frown, or if it's going to be a regular parabola, or if it's going to be a reflection, is the A value. Okay? If it is a positive A, it's going to be a smile. If it is a negative A, it's going to be a frown. Okay? Or it's going to be a reflection. And that is what controls two things. Okay? So the A controls the shape of the graph. So it controls the reflection, but it also controls whether or not I have a maximum or a minimum, which means it controls the vertex. Okay? Because here's my vertex. This is a maximum. This one is a minimum, which means it's a top or a bottom. And here's the other thing that happens when we have a parabola. We haven't talked too much about this, but there's actually a center. Okay, there's actually a center. And I know that you've seen Valentine's time. When you used to cut paper hearts, you'd fold your paper in half, and then you would cut out half of that heart, and it would open up to a full. So symmetry, the axis of symmetry goes through the vertex, and it shows that both sides are exactly the same. So if there's a point on this side, there's got to be a matching point on this side. Okay? So that's where that axis of symmetry comes in. And it is also controlled by the A, by the vertex. They're all connected together. So that A is the most important part of our graph. Okay? All right, so let's go ahead and see if we can put this together. So we're going to determine how many roots there are. If there are roots, we're going to find them using the quadratic formula. And then we're going to sketch a graph. Okay? And so we have to know whether it's going to be a smile or a frown depending on our A. And as we move farther into our unit, we're going to come up with the rest of the characteristics of the quadratic, including the equation of our axis, the y-intercept, our vertex, those kind of things. So let's go ahead and start this. So we've got A is -2, B is -8, and C is 10. So if I take a look at my B squared minus 4AC, I'm going to put in my -8, my -2, and my 10. Okay, so let's go ahead and get our calculator ready, because a lot of this, again, is calculator work. Okay, so -8, and I'm going to square it, minus 4 times -2 times 10. And I need a minus sign in there. Okay, so that gives me 144. So since this is positive, I know that there's two roots. Okay, I know that there are two roots. So now we're going to substitute into our equation. So we have -b plus or minus. My 144 goes right under that radical. Right under that radical. So now I'm going to put in my b again. So here's my -8, and my a is -2. You have to be very careful with not losing negatives on this formula, okay? All right, so to start evaluating this, negative is positive, so I know that 8 is there. Plus or minus, and 2 times -2, that's -4. Well, this 144 is a perfect square. Okay, it's a perfect square. So if I take the square root of 144, that's going to give me 12. So I have 8 plus or minus 12 divided by -4. So what this looks like is 8 plus 12 divided by -4 and 8 minus 12 divided by -4. So 8 plus 12 is 20. Divide -4 gives me a -5. So there's one answer. X is -5. The second one, 8 minus 12, that's -4. -4 divided by -4, that's 1. So my two answers are -5 and 1, because that would be -5 comma 0 and 1 comma 0. Okay, so I've got my two roots now. So is this a smile or a frown? Well, A is negative. So it's going to be a frown. It's going to be upside down. So I don't know how far up it goes at this point. That is something that we will determine as we move forward. At this point, I know where the roots are, and I know that it's a reflection. Okay, let's try another one. So in this case, we've got A is -2, B is +8, and we've got C being -8. So B squared minus our 4AC, so 8 squared, a -2, and a -8. All right, let's throw that in there. And I'm going to go ahead and just retype it into this one since I already have that formula in there. And you see that I get 0. Okay, this is 0. So that tells me that I'm going to come up with one root. Okay, one root. So let's go ahead and see what happens when I start to solve this. So my 0 is going to go here. My -2 is here, and my 8 is here. Well, the square root of 0 is 0. So technically, this part is gone. And I'm left with -8 over -4 plus or minus 0. Well, that's just -8 divided by -4. And that gives me a value of 2. So there's my axis, okay? Or there's my root. So that's 2 comma 0. So I do not have a second root. So what's happening is this one is only going to touch once. So this happens to be my vertex. Okay. Now, is this a smile or is it a frown? Well, A is negative, so it's actually going to be upside down from that point, moving down. Okay, upside down. It's a frown. It's only touching once. Okay, let's look at this one. So this one we're going to throw in a couple other things to be able to graph it. And we'll see more of these formulas as we move forward in our lessons this week. But this will help us actually sketch the graph. So A is 3, B is 6, and C is 8. So I have a 6, a 3, and an 8. All right, let's put those numbers in. A 6, a 3, and an 8. And you'll see that I get a -60. Well, if I try to put -60 in here, I can't do it. So this one has no roots. Okay, it has no roots at all, which means I do not have to do this part. Okay, because it's not touching it. There's nothing on my graph that's actually touching the x-axis. So I'm not going to touch my x-axis. So it's kind of hard to graph those if I don't touch it, if I'm not touching it. So what that tells me is I kind of need to come up with a couple of other values. Okay, so the y-intercept is actually my C. So my y-intercept would be 0, 8. So it would be touching here. Okay, and then the middle line is -b over 2a. So -6 over 2 times 3 is going to give me -6 over 6 is -1. So that tells me that the middle of my parabola is right there. So I can technically, from that point, I know since there's symmetry, if there's a point on this side, there's a point on that side. And I know it's not touching. So I can just kind of come down and go back up. And this one is a smile because A is positive. It's bigger than 0. But my axis kind of at least lets me get something going to be able to graph it. Okay, why don't you hit pause, see what you can do with this one. See if you can determine how many roots we have, and if there are roots, find them, and go ahead and sketch your graph. Okay, let's see how we did here. So A is 3, B is -6, C is -2. So I'm going to put in a -6 here, a 3, and a -2, and I come up with 60. Okay, so that means I'm going to have 2 roots, or x-intercepts. I'm going to have 2. So let's use our formula. So x equals, there's our plus minus, throw in our 60 in here, and 2 times A, and I need my B. All right, so here's where we see the decimals show up, okay? So if I take the square root of 60, I'm going to change this -60 to a positive 60, I get 7.745. We're going to round that off to tenths, and that's going to be 7.7. So negative negative is positive, plus or minus 7.7, 2 times 3 is 6. Okay, so to get these numbers, 6 plus 7.7 divided by 6, 6 minus 7.7 divided by 6. So 6 plus 7.7 is going to give me 13.7. If I divide that by 6, get on the right screen here, 13.7 divided by 6, I get 2.3. Okay, so the first one is 2.3. That's this one. All right, now let's change this to minus. And I get negative 1.7. And I can change this guy to negative 1.7. And it's going to give me negative 0.3. Again, we're going to round these to tenths because you can't graph. We have to estimate anyway, so there's no point in having multiple decimal points there. Just round it off to tenths. Okay, so 2.3 and negative 0.3. So 2.3 is going to be a little bit more than 2, and negative 0.3 is going to be on the other side. This is going to be a smile because A is positive, and I'm coming up like that. All right, so today you're going to be working specifically on discriminant. Remember, the discriminant's job is to determine how many roots there are and finding the roots using the quadratic formula. Okay, so make sure you've got that formula written down and the discriminant. Remember that if b squared minus 4ac is negative, then there are no roots. If it is positive, there are 2. And if it is 1, or if it is 0, then there is 1. Okay, those are the most important things you have to remember about the discriminant. All right, so see what you can do with that. Reach out to us if you are struggling, and we'll practice some more tomorrow.